Alright, so in this lesson we're going to be going through exercise 5a, which is all about the language of algebra. Our learning intentions: to know the basic terminology of algebra, to be able to identify coefficients, terms, and constant terms within expressions, including in situations where coefficients are 0 or negative, and to be able to write expressions from word descriptions. Let's first begin with a bit of a lesson starter here. So if we read this before us, this says, James normally runs 10 kilometers a day, but today James decides to run twice as far and then walks an additional 5 kilometers. Write an expression for the distance James traveled today. Well, if we know that he normally runs 10 kilometers, let's put 10 down first. We're then told that today he runs twice as far. Well, if he runs twice as far, that means we're going to multiply that 10 by 2. And then he walks an additional 5 kilometers, so we're going to plus 5 to that. We have therefore created an expression which represents how far James has traveled today. And we could of course go, well, 2 times 10 is 20, plus 5 is going to be 25 kilometers. Having now answered this, let's now read something over here which is very similar, and I want you to really take note of what's different over on this side. So here we're told James normally runs n kilometers a day, but today James decides to run twice as far and then walks an additional 5 kilometers. Write an expression for the distance James traveled today. Well, hopefully you noticed the difference. The difference here is we are told that James runs n kilometers. Well, how are we going to approach this question if we aren't told the number? Well, the way we're going to approach it is in exactly the same way. We're first going to begin by writing down n. We know that James normally runs n kilometers a day. We know that today James runs twice as far, so we're going to multiply that by 2, and then he walks an additional 5 kilometers, so we're going to plus 5 to it. Now, hopefully you remember from your basics of algebra that we don't like putting multiplication symbols here. So the way that we would actually write this expression is 2n plus 5. And that would be our expression. So as you can see, algebra is a tool that we can use of creating expressions when we don't know all the exact values. So here we have an n instead of an actual number. But let's say we found out what n was equal to. Let's say we found out that n was equal to 2. Well, then we could put 2 into here. So it would be 2 plus 5. 2 times 2 is 4, plus 5 is 9 kilometers. Or let's say we found out that James runs 3 kilometers a day. Well, instead of 2, that means we would end up putting 3 into this. 2 times 3 is 6. 6 plus 5 is 11 kilometers a day. So you can see the power of algebra there. But before we get into all of that, I really want to take this expression we have just created and talk about some key terminology. So let's come down here now. And as you can see, I have put down 2n plus 5. 2n plus 5. As I said there, sometimes I get mixed up between 2 and t. I say the wrong one, so be careful. T and 2, I don't know why. Okay, so let's go through some terminology here. The first thing we're going to talk about is what an expression is. So an expression, numbers and letters combined with any mathematical operation, so plus, subtraction, multiplication, or division. So this entire thing here is called an expression. So can you write that in for me? This entire thing is called an expression, and that's why we've got this big thing there over the whole thing. Next, pronumeral. A letter that stands for a number, and in brackets it says variable. So in this case, this n here is called a pronumeral. So this is very important. In algebra, we don't call them letters, we call them pronumerals. So get in the habit of calling them pronumerals. Now it also says variable here. Now the reason why we say variable is because the value of this n varies. As we saw up here, I could let n equal a number of things. I could let n equal 1, I could let n equal 2, and when I do that, it changes my expression, it changes the output of my expression. So that's why we call it a variable, because the pronumeral could represent any number. It varies. Okay, let's keep on going. Let's now talk about a coefficient. The coefficient is the number in front of a pronumeral. So in this case, it's going to be this 2. This 2 is a coefficient. And I want you to think of the word co-pilot or co-founder. Think of someone that stands next to someone else, and that's what a coefficient is. It stands next to the pro-numeral. Okay, let's keep on going. Next we have a constant. A constant is a term that does not contain a pronumeral. A constant is a term that does not contain a pronumeral, a number on its own. So in this case, this 5 is by itself. It doesn't have a pronumeral like over here. So we call it a constant. And we should think about constant as being an antonym to the word variable, because they mean the opposite thing to each other. So a variable changes, but a constant is constant. It never changes. So you're always going to be plussing 5 here. But this n here could represent any number. Okay, last one is term, a single number or pronumeral, or numbers and pronumerals combined with multiplication or division. So a term could be a single number. So that means our constant here is a term because it's just a single number. It could also be numbers and pronumerals combined with multiplication or division. Well, in this case, this 2n, we know that these two things are combined together by a multiplication. If you remember up here, we had 2n, 2 times n, and we made that 2n. So that means this thing right here is a term as well. And we'll be learning more about terms later on. Okay, so having now gone through all of that, it's really important that you know what an expression is, what a pronumeral is, what a coefficient is, what a constant is, and what a term is. We'll be seeing more of these very soon, but it's important that you have a good grasp of them now. Before we go on, I just really want to touch upon this, which you probably remember from last year, and that is, in algebra, we always write expressions without multiplication signs. So A times B is written as just AB. We don't put the multiplication sign in, we just treat that multiplication sign as invisible. So what we're going to do now is write the following without the multiplication sign. So 7 times B would just be written as 7B. Y times 27, well, that means y times 27, I'm just going to write it like this. Now, it's important that you always put the number first, because remember, up here, it's like the coefficient. It is the coefficient. The coefficient always goes in front of the pronumeral. So always put the number first. So over here, we would write this like that, with the 8 first, then the A and the B. Over here, we would write that like this, and this last one we would write like that. So no multiplication sign. Instead, when they are being multiplied, we just put them right next to each other. Okay, let's keep on going now. In algebra, we also don't like writing expressions with division symbols. So instead of writing A divided by B, we would write it like that, just A over B. So let's now rewrite the following without the division sign. So instead of 3 divided by 4, we would write 3 over 4. So 2 over here, and over here, and over here, over here, and lastly this one, which will be written as that. Perfect. So that is how we would do it. So it's very important that you realize that we don't like writing that division sign and we don't like writing that multiplication sign. Okay, let's keep on going now. Let's come down here. So our next one is we're going to go through some examples of terms. So just to really make sure that we have a good understanding of them. So first we've got our definition of what a term is. A term, a single number or pronumeral, or numbers and pronumerals combined with multiplication or division. So let's look at this one. It says state the individual terms in the expression. So we need to figure out the individual terms in this expression. I'm going to get my highlighter out. This is my first term, 3a. So it is a number and a pronumeral joined together with a division, with a multiplication. Because remember, there's an invisible multiplication sign between those two things. Our next one is going to be this, negative 13. It's important that you include the sign in front of the pronumeral or the number in this case. And then the next one is going to be plus b. And again, you have to make sure that you include that sign. So hopefully you can see there that we have 3 terms. We have 3 terms. And those 3 terms are going to be 3a, it's going to be negative 13, and it's going to be positive b. Okay, let's now look over here and see if we can figure out how many terms we have here. The first one is going to be 4q. So this is a number and a pronumeral joined together with a multiplication sign. The next one that we have is going to be positive 10r. So again, make sure you're including the sign in front of it. And this time we have a number and a pronumeral joined together with division. But this is one term. The next one that we have is plus 1. So that's just a constant. And then lastly, we have minus 2t. Again, take note of the fact that I'm including the sign in front of it. So that means altogether I have 4 terms. And the 4 terms are going to be 4q, 10 over r, positive 1, and negative 2t. Okay, let's keep on going now. So here we have coefficients. So let's remind ourselves of what a coefficient is. A coefficient is the number in front of a pronumeral. Okay, these are some very important bits of information. It says if the term is being subtracted, the coefficient is a negative number, and if there is no number in front, the coefficient is 1. Okay, so what we need to do here is state the coefficient of b in each expression. So right here, you can see I have 1, 2, 3 terms, and here is my b, and the number in front of my b is 3. So that means the coefficient of b is 3, because it's simply the number in front of b. Let's come and look at this one now. So what we're trying to find here is the number in front of b. So there is my b term, and the number in front of it is going to be 10. So it's going to be 10 here. Let's come over here now. All right, so I need the coefficient of b. Now here I have 4ab, but that's not, I want b by itself. I don't want ab, I just want b by itself. So too over here, well, this is z, so that's clearly off the table. That's off the table. I want this one. This one is just b by itself. And the coefficient, and I'm actually going to make this very clear here, the coefficient is going to be minus 5. And this is this term right here. It says if the term is being subtracted, the coefficient is a negative number. So you don't just put 5, you make sure that you put minus 5 or negative 5. So that is the coefficient because I have a minus in front of that 5. Okay, let's come over here now. Here I have 5 minus 5ab plus b. Again, don't be confused by the fact that we have ab here. This does not count. We just want b by itself. Now, here's another important thing here. What is the number in front of b here? You might be thinking it's 0 because there is no number there. But remember this statement here. If there is no number in front, the coefficient is 1. So that means over here, the coefficient of b is 1. Now, the reason why that's true is because if you were to think for a moment, if I had 3 b's, that's the same as 3 times b, which is equal to 3b. If I had 2 b's, that's the same as 2 times b, which is equal to 2b. Well, if I had 1b, that's 1 times b, which is 1b, right? But in algebra, we don't like putting that 1 in front of it. We don't like putting this 1 here. So instead, we just write it as b. Just like this, we just write b. If I had 0 b's, that would mean I have 0 times b. And what's 0 times any number? Well, just 0. So if I wanted to say that there are 0 b's, I would literally just put a 0 there. But because I have just a b by itself, that means my coefficient is 1. Okay, let's keep on working here. So let's go again. So remember, the first thing we have to find is my term with a b in it. So 3a doesn't work, 4ab, that doesn't work. Here I have 5b squared, but remember, I just want b by itself. The fact that it's squared means it does not count. So that means over here, my coefficient of b is just going to be 7. All right, over here, well, that's a 5, that's bad as well. Here it's going to be negative b. So that means there is an invisible 1 in front of that b. And remember, I need to include the sign in front of it. So it's going to be negative 1. It's going to be negative 1 there. All right, let's keep on going here. This is 5b squared plus 7ab. So I just want b by itself. So those don't count. And here is my b. And I want to read the number in front of that b. So it's going to be negative 2. So that means right here, it's going to be negative 2. And then the last one, that's not going to count, that's not going to count. We've already seen this before. When there's a negative and then nothing there, that means there's a 1 there, so it's going to be negative 1. Okay, so having now done that, let's keep on going and talk about some constants. Constants are easy. Constant, a term that does not contain any pronumerals, is called a constant term. So what is the constant in this expression? Well, as you can see, I have 1, 2, 3, 4 terms, and this term right here doesn't have any pronumerals. And remember, a term that does not contain any pronumerals is a constant term, so that means my constant term is 5. For this one, what is it going to be? Well, I have 4q minus 10r plus 1 plus 2t. What term there doesn't have any pronumerals? It's 1. So that means 1 is my constant term. Let's come over here. I have 3a, 4ab minus 20, 5b squared. So for this one, and this is the important part here, it's quite clear that the one that does not have any pronumerals is here, but you always have to include the sign in front of it. So that means it's going to be minus 20 or negative 20. And then the last one here is going to be this one right here, negative 82. Perfect. All right, so let's now come to our very last question for this lesson, and then in the next lesson, I'll go through the second part. All right, so bringing it all together, we need to give 2 examples of an expression with exactly 3 terms. One term is a constant, one term has a coefficient of -4, and one term has a coefficient of 1. Okay, so if one term is a constant, that just means one term is just going to have no pronumerals attached to it. So let's just say that's 27. One term is going to have a coefficient of -4, so that means it's going to be -4a, or whatever pronumeral you like. And then one term is going to have a coefficient of 1, and we know that if it's going to have a coefficient of 1, it's just a pronumeral by itself. And that is my first example. Remember, we have to give 2 examples, so let's write down another. So remember, it has to have one constant term, so let's say 102. One term has a coefficient of -4, so that's going to be -4z. And then one term has a coefficient of 1, so let's say plus t. Perfect, so there are 2 examples of those right there. Let's now answer this one. Again, 2 examples of an expression with exactly 4 terms. One term is a constant. Well, if one term is going to be a constant, let's make it 56. One term has a coefficient of -1. What that's going to look like is this, negative w. So remember, if it has a coefficient of 1, you don't put any number in front of it. And because it's -1, there has to be a negative sign there, or minus sign. And one term has a coefficient of 9, so let's make that 9m. And it says it has to have exactly 4 terms, so I'm going to have to add another term here. Let's make it, I don't know, 4 over j. Okay, we have to give 2 examples. Let's do the very last one. So I need to write down a constant term. Let's make it 1278. So remember, it just can't have a pronumeral attached to it. One term is going to have a coefficient of -1. Let's make that negative k. And one term has a coefficient of 9. Let's make that plus 9 v. And then I have to add in just another term, whatever that may be. So let's just make that plus j. And that's another term there. So I have 1, 2, 3, 4 terms, just like that. Beautiful, followed all my directions. Perfect. So hopefully you feel comfortable with everything we've gone through here. So this should be more or less just a refresher of what you've done last year in Year 7 Algebra. And yeah, hopefully you found it doable. So we've done that and we have done that. So in the next video, I'll record myself going through the second portion of these notes. I just don't want to make it too long. All right, I'll see you then.